State if each triangle is a right triangle. This uses a little thing called the converse of the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. Usually we use this guy to find missing sides of right triangles. Well, in all three of these cases, I'm given all three sides. So what I have to do is use this guy to make sure that these are right triangles. Now, what does that look like? I go to one of my triangles and I label the three sides A, B, and C. But oh, do be careful. Because whenever you label A, B, and C, you must call the longest side C because the longest side would be the hypotenuse in this case. It doesn't matter which one A is. It doesn't matter which one B is. And what you do, now that we have things labeled, is you plug it into this formula. So A squared is 12 squared plus B squared is 9 squared equals C squared is 15 squared. And you might be thinking, what are we solving for? Nothing. The goal of using the converse of the Pythagorean theorem is to make sure our math works out. If it does, it's a right triangle because it works for the Pythagorean theorem. If it doesn't, it's not a right triangle. It's still a triangle, but it's not a right triangle. So let's do the math. 12 squared is 144. 9 squared is 81. 15 squared is 225. 144 plus 81 is 225. Does 225 equal 225? Last time I checked, yes, it does. So this first one is a right triangle. Okay, let's try it again and again. So I have to label A, B, and C. Which one has to be A, B, or C? Well, A and B doesn't matter as long as you call the longest side C. So I'll call you A and I'll call you B. So 10 squared plus 49.5 squared has to equal 50.5 squared. 10 squared is 100. 49.5 squared is, let me do the math in my head, 2,450.5. And 50.5 squared is 2,550.25. I meant to put a 2 here. I don't know if I said it and just typed it or wrote it out wrong, but there you go. So, okay. 100 plus 2,400 blah is 2,500 blah. That equals 2,550.25. So since the both of them equal each other, even though I have a little writing errors here, I fixed it, and yes, it does work out. Okay, so not as pleasant, but you know, I did the math in my head. I did. Last one. Now, I don't know what the square root of 115 is, but I do know that the square root of 121, which is 11, is 11. So this has to be C here because 11 is going to be bigger than the square root of 115 because 121 is 11. So I'll call you A, I'll call you B, and I'll set it up. And you might be thinking, oh, no, square roots. Don't worry about it. It's actually not bad. I have 9 squared plus the square root of 115 squared has to equal 11 squared. 9 squared is 81. 115 squared cancels each other out if I square root it. Happy days. 11 squared is 121. 81 plus 115 is like 196 or something, which is certainly not 121. So nope. All right, so this is how you use the converse of the Pythagorean theorem. I give you 3 sides. I ask you, is this a right triangle? You determine which one has to be C, and the longest one's always going to be C. You plug it in, you make sure it works, and if it does, it's a right triangle. If it does, if it's a right triangle. If it doesn't, it's not a right triangle. Not bad.